Good morning, everybody. My expertise as far as the IT industry is concerned is in building the physical infrastructure that goes into data centers. Okay? Now, when we say physical infrastructure, I'm talking about absolutely non-IT stuff. It's the civil and interiors, the electrical, the DG set, UPS, security access, physical security access, CCTV, fire detection, fire suppression, that kind of stuff. Now, no matter how good your IT equipment is and your communication routers, switches are, none of it can work unless you have a very secure and reliable data center. Most of the failure or non-availability of IT in any organization, I think 70%, the last measure that was taken, is attributable purely to the physical infrastructure failure. That's failure of air conditioning, failure of power that causes downtime in the data center. Downtime caused by server failure is very rare because there's a lot of redundancy built into the construction of the IT equipment, and therefore it becomes very, very reliable. But from the power and air conditioning point of view, you've got to be very careful. Now, you all must have all heard about Moore's law, which says in about every 18 to 24 months, the capacity available, computing capacity available per square piece of area is doubling, right? Now, this is very good as far as IT is concerned because you are getting, and the price drops, you are getting much more computing power in a more limited space than before. But this same Moore's law has been the major cause for headache in building and designing the data center. Because with the compactness, now in the introduction given by Mr. Singh, he said that I have seen 100 MB disk drives, a big cabinet like this of 100 MB, and today you've got 320 GB in a small cigarette pack. Now, what does this kind of miniaturization mean as far as the physical infrastructure is concerned? That's the power and the cooling. That means that there's been a huge explosion. It's about 30 to 40 times the amount of power required and cooling required per square foot of data center space, right? So in any attempt to build a data center, the two most critical issues that you must address is the power and the cooling, right? Now, this then translates to the selection of the site. Typically, the state data centers, people would tend to locate it in an existing office building. I would like to sound out the warning that most or practically all typical office buildings currently in use in any part of India is totally unsuitable for a modern data center. The reason being is that when you want to effectively supply power of such concentrated this thing and then cool it, then the slab to slab clear height in your data center, the absolute minimum is about 13 feet. You cannot build a modern data center without a slab to slab clearance of 13 feet. Today in any Delhi office you walk in, the clear height between the bottom of the beam and the slab, you'll be lucky if you get about 10 or to 10.5 feet. It's round about there or less. There is no building that's got better space than this. Therefore, you've got to select a space that gives you this clearance. Now, this clearance is actually, it's not a luxury, it's absolutely necessary for the adequate air supply. Because why do you need this height basically? The floor void where the supply of the air conditioning air is going to take place, and the ceiling void where the return of the air conditioning air is coming back to the precision equipments, right? So every centimeter, every millimeter of this 13 feet height is required and can be proven as this is what you need to cool your data centers. The other thing is that the slab, a typical slab load today in an office building would be between 300 to 450 kgs per meter squared. That's the load it can take. What do all manufacturers, whether it's HP, Sun or IBM, what are their data cabinets and the big storage, like IBM's P series? Each rack weighs 1.2 tons. The footprint is little more than a meter. So your 300 to 450 square foot slab that has been designed to take that kind of load, it's definitely going to be a challenge where you keep this. And you put 3 or 4 of them together, and you'll find that cracks start appearing in the slab below, on the floor below. So with these constraints in mind, you've got to be very careful in selecting your site. Be very careful. The slab height is required and the strength of the slab is required. The third aspect is adequate power supply. Now I'll give you an example. We are building a data center in Bombay for the UTI Bank. That building is about a 14-story, it's a new building that's coming up. And the data center is on one particular floor. The total area is about 10,000 square feet. Now, when we did the power requirement and put it up to Reliance, who is the power supply in that area, and we told them that for just this one floor of 10,000 square feet, we want 1.8 megawatts of power. There was total disbelief. They said, no, there has to be a mistake. This is wrong. You can't be right. I've got a 800 kVA transformer for my whole building. Right? And you are telling me that you want 1.8 megawatts for one floor? Mistake. Now, when we put up a figure of 1.8 megawatts, it is basically totally based on a tabulation of what is the equipment going in. It's not guesswork. I have not pulled that thing out of my hat that I want 1.8 megawatts. I put in all the equipment that goes in. I put in the air conditioning load that is required. What is the UPS that's going in there? And therefore you tally it up and you total it, and it comes to 1.8 megawatts period. This includes, of course, the future expansion of the planned future expansion of the company. So providing this to Reliance, and then they realizing that it is based on facts and it is required, was very easy. But now we come to the other point, that if Reliance is supplying, they're supplying the whole of that area, right? Now when they have this 800 kVA transformer which they plan for the whole building, the back-end infrastructure, the cabling, the HT cabling, all that needs to be augmented, right from maybe the main HT substation where they're drawing it from. So the entire route needs to be looked into. Now I don't know what are the sizes that the state governments are looking for their data centers, but if it is anything near, say 10,000 square feet or even 5,000 square feet, because at 5,000 you're looking close to 800 kVA just for that data center power requirements. You've got to be careful in selecting these sites. Now, sometimes what happens is people just go and build. They say, okay, let me see, I'll build this data center, without thinking that what are the industry standards today. Today, a very conservatively sized data center, you must plan for an energy loading factor, because many times you don't know what equipment, you've not yet decided whether you're going with Sun Systems or HP or IBM or what. So you don't know what is the actual load that your data center is going to be requiring. So we go by the industry standard today, and that is about 100 watts per square foot. You must plan for an energy utilization of about 100 watts per square foot. Multiply that into your data center, you'll get your total energy requirement for the IT equipment itself. Add to this the additional power that will be required for the cooling, and you'll get the total power requirement, right? So the next thing, I've given you the pitfalls as far as selection of site is concerned and things like that. Now comes to the design. Now, as far as the air conditioning is concerned, it is a terrible challenge to cool when you're loading a data center at 100 watts per square foot. You'll get the heat requirements. Cooling that has become a very big challenge. Now, in cooling, typically when you go to AC consultants, they look at basically the tonnage. They say, okay, you need 100 tons of air conditioning. Simple, we'll put 100 tons of cooling equipment and your problem is solved. Where it's required, getting it back to the equipment properly without, being the hot air getting drawn back into the cabinet that requires cold air is again a challenge. Therefore, you need expertise in